to learn some math. Learn some math.
Alright, so now we're going to talk about systems of equations again, except for today we're going to work on solving systems of equations that are embedded in word problems. Okay, so your learning target is I can solve for solutions of systems of linear equations that are in word problems. So when you're faced with word problems, there's a certain amount of steps that are a good idea to follow in solving word problems. And the first thing that you're going to want to do is you need to understand the problem and list out essentially what is the important information. What is the vital information that you need to know? Okay, so important is that first blank. After you list out some important information for this type of problem, you need to write a system of equations. We need to write a system of equations based off of that important information. Third step is to solve the systems problem using one of the methods. Okay, that was the graphing, substitution, or elimination. That makes the most sense, the one that makes the most sense to use for the certain problem. And then finally, the last step would be to check your work. So let's talk about what method makes the most sense to use and when should you use it. Okay, so the first method we're going to talk about is graphing. Okay, graphing. Now, when you should use graphing is if both equations are already solved for y. And the reason for that is because when you have two equations that are already solved for y, it's pretty easy to go and just plug that information into a graph because it's already in slope-intercept form, right? An example of this might be y equals 5x plus 1 and y equals negative 2x minus 4. Because if you just graph those real quick, you'll be able to see how they intersect with each other. Another time when you should maybe use it is if you're estimating. Okay. The second method is substitution. Okay. The idea of when you want to use substitution is if a variable in either equation has a coefficient of 1. When you have a coefficient of 1, it's pretty easy to solve for that variable. You just subtract whatever's to the other side, and then you can plug that information into your other equation. Just like this top equation here, if we were to just subtract 3y from both sides, we would get x equals negative 3y plus 5. That'd be pretty easy to plug that in for x in the other equation and solve. Okay. The second one would be both equations are already solved for the same variable. So if you have two equations that are already solved for x, that might be a good idea. And the last one is either equation is already solved for a variable. So like this one, you see x is already equal to 5y minus 2. All you have to do is just substitute that in for x and then solve for y. And that's not too difficult to do either. Okay. Now this last method, remember, is elimination. And the times to use elimination is if both equations have the same variable with the same or opposite coefficient. Kind of like this problem up here where we've got 5y and 5y. We could just subtract those pretty easy to cancel them out, and then we're going to have 2x equals 3. That's really easy to solve. So elimination, when you have two variables or the coefficients of the same variable the same or even opposite, meaning one is positive, one is negative, that's pretty easy to do to use that one. And the last one would be a variable term in one equation is a multiple of the same variable in another equation. Kind of like this problem here, we know that we would just have to multiply everything by 2 in order to get these to both be 8x. Then that's a little bit easier to solve. So those are just some suggestions on which how to determine which method to use if you're not given instructions on which method you need to use. Alright, example 1 is a word problem. It says the school that Matt goes to is selling tickets to the annual dance competition. On the first day of ticket sales, the school sold 14 senior citizen tickets and 5 student tickets for a total of $86. The school took in $100 on the second day by selling 7 senior citizen tickets and 12 student tickets. We want to find the price of a senior citizen ticket and the price of a student ticket. So remember, the very first step in solving these types of problems is first list out the important information. Important info. Okay? Now on the first day, They sold 14 senior citizen tickets and 5 student tickets and made $86. Okay, so that's pretty important. So 14 senior citizen tickets, and I'm going to go ahead and call those C, okay, for senior citizen. You want to maybe put in variables. That'd be a good idea. They sold 5 student tickets, and we'll call that S, for a grand total of $86. Okay. Second day, we're just listing the important information that we were given. The second day they took in $100, 7 senior citizen tickets and 12 student tickets. So we have 7 SC. We'll call that C. I'm just kind of shortening this. We know what we're talking about here. And 12 student tickets, S, for a total of $100. Okay, so listed the important information now, and the second thing is we need to write a systems of equations based on this important information. So we know that there was 14 senior citizen tickets, so 14C, plus the 5 student tickets, plus 5S, and that totaled $86. And the second day we sold 7 senior citizen tickets plus 12 student tickets, and we got $100. Okay, so we set up that equation, and the third step would be to solve the systems of equation. So we kind of have to decide which method we want to use. So I'm going to move this up a little bit. We need to decide which method we want to use, and remember that the easiest way to, if we wanted to graph it, we would want it solved for y. We don't have either one of them solved for y, so that's not necessarily going to help us. And we're not even really talking about y and x. We're talking about c and s, so that kind of gets confusing for us. The substitution we want to use if we have a coefficient of 1, which we don't, or if we can solve for a variable pretty easily, and we don't. So substitution wouldn't be a good idea, but elimination, if you look at elimination, remember elimination said that if a variable term in one equation is a multiple of the same variable in another equation, then that might be a good one to use. And we see 7c goes into 14c twice. So if we multiply this second equation by 2, multiply it by 2, this is kind of 3, and 3 is going up here, step 3, we would get 14c plus 24s equals 200. Now we can take away, we can subtract the two equations from each other and see what s is equal to, right? So let's do that. I'm going to write this equation now over under here. That was 14c plus 5s equals 86. And we're going to subtract these. That means we're going to subtract 14c, we're going to subtract 5s, and we're going to subtract 86 to cancel our senior citizen prices out, right? And we're going to get 19s is equal to, this is going to be 114. Okay, now it's just solving for s. So we're going to divide by 19 on both sides, and what we end up getting is s is equal to 6. So that means the cost for the price of a student ticket would be $6. Now that we know that that's 6, we can plug this information back into one of the equations in our first equations here. Plug the solution for s back into the equation of the first one. So I'm going to go ahead, and this is 100 is an even number, so I'm going to go ahead and use that one. We've got 7c plus 12s, but remember s is 6. That equals $100. And now we can figure out how much each senior citizen price is. We're going to have 7c plus 12 times 6 is 72 equals $100. Minus the 72 on both sides, we're going to get 7c is equal to 28. Divide by 7, we end up getting c is equal to 4. Oop, looks like I cut it off a little bit. C is equal to 4. So that means, what that means then is that student ticket is $6. Senior citizen ticket is $4. Okay, and the last thing we can do here is just to check our work. So I'm going to choose one of those equations here. We're going to choose the top one this time and plug these numbers in and make sure that everything works out. So 14 times 4 instead of C plus 5 times 6 is supposed to equal 86. We just want to make sure that this works. 14 times 4 is actually, if you do 15 times 4, that's going to give you 60, right? And minus 4 from that will give you 56. Plus 5 times 6, which is 30, is supposed to equal 86, and we see that it does. So that we checked our work, we did it correctly. So this truly is the correct answer.